Okay, we're going to write an algorithm that will merge two linked lists that have been sorted in ascending order. So if we had 4, 5, 9, and 20, and we had 3, 6, and 10, then we would have an outcome of 3, 4, 5, 6, 9, 10, and 20. So the goal would be to just do this in line without using any additional data structures. So let's go ahead and think about how to do this. If I have a 10, a 20, and a 30, call that first. And then if I have 5, 15, and 25, we'll call that second. So the first thing we want to do is make sure that we're always inserting into the same list as the one we're going to. We'll always want to do it into the first. So what I want to do is get my first to be pointing at the smallest data item. So to do that, we can compare the first and the second, and then if second's data is smaller than first, then we can just swap them. So that becomes second, this becomes first, and this way all my operations will be organized and make sense to start like this. So what we'll do is we will insert, we'll go through and we'll say, okay, let's compare these. I want to kind of start comparing from first.next. So we'll look at, is first.next bigger than the second? In this case it is, so we know we need to insert second. So we would end up having 5, 10, 15, 25 into first. And second would just kind of move to here. And then we would look again and we would say, and actually first was, we were looking here, so this would then become first. And we want to save this head too. So then we keep moving on and we would look at first and second, or first, next, and second. In this case, first, next is smaller than second. So we know that we would want to insert, we would want to insert second after this 15. So we can actually advance first one more and then look at first, next, and then look at the second. And then we see that 25 is bigger than 20. So we'll end up putting the 20 here. We'll end up putting the 25 there. And this becomes second. And then we would increase first and look at first, next, which is 25. It's smaller than 30, so we know that we're going to have to put 30 on the end here. And it's null. And then 1 second is equal to null, and first is equal to null, or even 1 second is, we know that we are done. So that's kind of the gist of it. So let's go ahead and code this. And I think I will keep the pictures to kind of help out. So that was 10, 20, 30, and this is first. This is null. And then we had second had 5, 15, 25. Okay. So the first thing we said we wanted to do was to test and see which linked list should be our first. So let's write this out. So public, we're returning a node, we'll return the head of the new merged list. And we call this merge. And it's going to take in a node of first and a node second. And then we're going to do that test. So if first .next.data is greater than second data, then we want to do a swap. So we'll have a temp, and that's going to equal first, then first equals second, and second equals temp. Just a basic swap. Okay. And so then say we've swapped them. We've got first, we've got second here. So then we need to assign our head to first. So okay. And then we know we need to start a while loop. So while first dot next does not equal null, and second does not equal null. And we're always wanting to kind of look at the first dot next because that's more interesting to us than where first is, because we've already looked at first. And since they're already sorted in ascending order, we need to always be comparing the second item to see if it should be going after first, but before first dot next is kind of what we're trying to say. So if first dot next dot data is less than second dot data, that would tell us that we don't want to put second in front of first. We want to move first forward. So then we'd move first equals first dot next. Okay, else this is where we'll swap around. So we would say we'll have a next node equal to first dot next. We're just creating some placeholders as we move things around. So this becomes next. And we have a temp, which is basically the next element for our second list. And temp is going to be second dot next. So that's going to be here. And then we want to do first dot next. Then we do first dot next equals second. And so that's what's going to put this equal to, that's going to put this equal to the, like pointing at our second element. And then we need to point our second equal to first dot next. So then the second is going to be pointing to first. And then we need to increase. So then first becomes first at next. And second equals temp. Okay. So what we have is first is going to equal first dot next. So first is now here. And second equals temp. So this is now second. All right, if we redraw this really quick, we're going to end up with 20 and 30. And this was second. And then if we look at the other one, we've got 5, which is our head, 5 points to 10, and 10 is first, and 10 points to oh, it looks like we put this a little bit off. Okay, so 10 is supposed to point to 15. I think I just drew my arrow to there. So 10 is supposed to point to next. So that was second. So we went second dot next equals next, not first dot next. That makes more sense. Because first dot next will already have been changed. Which means that, okay, we've got 10, and then that goes to the 15 and the 25. That's still long. Okay. So those are kind of our new fresh drawings. Kind of clean this up a little bit. Okay, so we did that, and then that's our else. And then we know that when we get out of the while loop, because we've hit the end of first or second, then we'll do that quick check that we talked about to make sure that if there's still items in second, we just want to append those to the end once we've gone through all of first. And since it's in ascending order, it will still all be in order. Okay. And then at the very end, we're going to return head. Okay. So let's kind of go through this code and make sure, especially since we made a change on the fly. Okay. So here's kind of where we're at with this is, or I guess let's go ahead and start over and do it all from the beginning just to make sure since we made that change. So if we have 10, 20, and 30, and this is first, and that's null. And then if we have, we'll do 5 and 15. And we'll call this one first. All right, they're going to pass into our function. And we probably should add some tests to say if first or second equals null, we need to act appropriately. So then we go in and we say if first.dex.data is greater than second data, so if 15 is greater than 10, which it is, so we want to swap first and second. I mislabeled that one, but we're swapping anyway. So we're swapping first with second. So this is now second. This is now first. Okay, and then node head equals first. So this is head. Okay, while first.next does not equal null, and that is true, and then second does not equal null, which is also true. Then we go in, if first.next.data is less than second's data, that's not the case, so we don't do that. Else, next equals first.next, so this is next. Node temp equals second.next. Here's temp. First.next equals second. Okay, so that's going to end up pointing to second. So let's go ahead and make room for this. And second ends up pointing here. Okay, so then first.next is now second. Okay. And second.next equals next. So that's this guy. Okay, we'll just move this guy there. And he's still pointing to null. Okay, and then first equals first.next. So here's first, and it's going to go to its next. And second equals temp. So here's second. Okay, and then we go around and we look at, well, first.next, which is our 15, is less than second's data, which is 20, which it is. Then first equals first.next. So first is going to go here. Else we have next is going to equal first.next. So here's next. Oh, we don't actually do that. We just did the if statement there. So skip that. We go back and now we say, well, first.next does not equal null. Well, first.next does equal null. So we don't mean that condition. So we get out of our while loop and then we say if first.next equals null, which it does, then first.next equals second. So second is up here. It is our 20. So what we can do is we can move our 20 down here and go ahead and assign first.next equal to second. So it's no longer null. And then we have our head up here, so that's the no we're returning, but we have our full linked list of 5, 10, 15, 20, and 30, and we'll return 5. So it looks like this is going to work, other than needing to add in a couple of tests just to make sure that our nodes that were being passed in are not null, and then we can handle those appropriately. And again, it's an O of N solution, worst case, but it could be less than that if we end up being able to not go through those last parts of the second list. And it's in O of 1 space.